Hello there! In today's video we're going to talk about tags and user-defined tags, aka UDT, so stay tuned. Hello folks, welcome back to RTF M. I'm Roberto Cruz, and in today's video we're continuing on the quick start steps. We're nearly there, we're nearly done. So in today's video we're going to talk about tags and user-defined tags, right? I think this is the, I don't think it's the last subject on the quick start steps, but it's among the one of the final topics, right? Obviously, for those of you who are just landed here, we are a channel that we talk about operation technology, industrial automation, and PLC programming, SCADA. So if you're interested in the subject, so feel free to subscribe to the channel. And make sure you follow us on our social media, especially on Instagram, where we are actively posting and engaging with our followers. So, I'm going to leave all the details on the description of these videos so you can find us on @RTF_M on Instagram. All right, so let's just dive into the subject. All right, let me just create that. By the way, guys, you might see that I've got an unusual setup today, so it's because I'm obviously working away, so I'm on the road, and this is just a hotel. My obviously my scenario is basically my hotel room. All right, I hope the sound, I hope I don't lose quality. Just using my earbuds here so we can record the mic. So hopefully that won't be an issue. All right, let me just switch screen so we can dive right into the subject. Okay, 1 second, here we go. All right, folks, so basically today's video we're going to talk about tags, right? So obviously we've already, I'm going to leave a link here on this video. We've made a video about how you can create a new tag. How can you can actually create a base tag, either a base tag or an alias. So we went through that. So we're gonna leave a card on these videos, somewhere in these videos, so you can find out. I think it's probably within this playlist. I've also covered that topic into our Logix Emulate playlist, but. I'm just going to drop off a card on this video so you can find that easily. All right. So as you can see here, so I've got just some lines of code I've written. So there are various tags, right? So basically I've written just some lines of code, and I call it routine, right? Motor. So this is basically, it's a very actually comprehensive logic, so you can control a motor, right? A motor. So it could well be a motor, like for a conveyor belt or a pump. So let's just imagine this is for an actual pump, for instance. Let's say. So I'm going to go through very briefly because we're not discussing the control itself, right? We're going to be talking about. In today's video, I said tags, but it's going to be basically user-defined data types. This is the most important subject of this video, right? So just a quick introduction. But basically, the core of the control systems is being able to define your operations based on data stored in tags. Tags support different types of data, which define the size and layout of memory that is allocated for the tag. So data types can be atomic, structure, or array. So the atomic data types, those are predefined data types that are used to compose member data. All right. So I can tell you a few. For instance, we've got Boolean, right, which is obviously either 0 or 1. So it's called bool. We've also got a cent, right, which is basically 1 byte, so 6 bits. We've got an integer, for instance, which is 2 bytes, right? We've got double integers, which is 4 bytes. And we also got, those are the most common ones, right? So those are called atomic data types. So they are predefined and you can find them on the controller, right? And obviously we've got real, which is the 4 byte floating point number. Okay, like for instance, A byte varies from, the range is from -128 to 127. An integer goes from minus 32,768 to 30 plus 32,767. And wow, 4 bytes, you can imagine, it's just a large number. I'm not gonna read that out. It's 2 million, and something, minus and plus, right? And we got some crazy for the real, for the floating point, we got some crazy engineering unit here just to demonstrate the size of the number, right? I'm just gonna drag this out and I'll show you guys. I think it's gonna be easy. Let me just drag, I'm just leaving in here. Let me just show you guys. So those are the atomic, right? Atomic data types. But those are those are the most common ones, right? There are obviously various other types that we can call atomic. Let me just take that off the screen so I can continue and we can show you software Logix Designer. Right, so again, so we've got the atomic type, data type, and then we've got the structured data type. What is it, this structured data type? So data type, the structured data type is a data type composed of a sequence of members. A structured tag occupies a contiguous block of memory in the controller with each member in sequence in memory. And then we finally got the array data type. So the array data type is basically a matrix. So you can pick up, for instance, a double integer, right? So you can set the size of this array. So you can have a tag called double integer A, for instance, and that could be composed of 10 elements, so a size of 10, right? So this is the dimension. So basically, an array data type is a data type composed of a matrix of members. Arrays can have multiple dimensions, but all members must be of the same atomic data type. So this is the array data type, right? So, and the user-defined data is basically basically sitting on the second one called the structured data type. So you can have several different types of data sitting on your user-defined data. So the UDT stands for user-defined data type, right? I'm going to show you guys how to create that. So, but before we just dive into how you can create your own data types, I'm just going to show you what I've done so far, and then to be able to show you guys how it works easily. So basically, like I said, so those lines control a single motor, right? So I'm just going to ignore, you see where we've got dummy bit, which is basically, so those four first lines, the first 4 lines, I've just created them so I can actually manipulate those bits through the ladder logic, so I can control the mode to change, for instance, from local to remote mode. I can actually send a manual start command from a Hmi. For example, Hmi str push button is a start command. And so this is just for me to manipulate. For the rank number 4, right? I'm just going to select it here so it's easy for you to see. From rank number 4 downwards, so all those ranks are the actual logic. So those are the lines that we're going to be using to be able to show you guys the user-defined types, right? So this is just a simple ladder logic, very, very simple. So the first bit here is doing pretty much like a first scan setup. So basically, every time your PLC cycles the power, so it runs its first scan, it's going to set up, those set points. So this is like the default set points. So every time you're cycling the power, you're going to load up the required set points, right? Simple as that. So those are actually the set points from the Hmi. So you can write them down and obviously allocate those set points and write them down to your application. So, and then we've got, I'm just going to go very briefly. We're not going to discuss that in depth, right? In the future, in the next video, actually, we're going to talk a little bit. We're going to talk about the actual code, the actual logic, a bit more in depth. All right. So as you can see here, you've got a local remote. We've got a manual start request. We've got an auto restart request. We've got the latch and unlatch, right? I've done here, this is let me just correct this. I think this was a mistake I've made. So this is output motor, right? Yeah, so this is also, yeah, don't worry about that. I think I just messed up with the code, but I'll fix that later, right? So then we've got, you know, another memory here. So you can turn it on, turn it off, and you've got your simulation. So you can either issue your running signal through the actual hardware for an input. It could be the actual speed of the motor, or a running signal that is wired back to the PLC. We've got permissive interlocks. We've got actual interlocks. We've got the motor healthy, so all the alarms attached to the motor. So it's a quite very comprehensive logic for a single motor, right? And the reason I've written these down, so it's going to be easy for you guys to understand. So basically, every single bit within this logic, it's going to go back here. So you have an I, which is an input, right? So everything else, like this, local remote, those are internal memories that are allocated to the PLC. So we've got like a local remote switch, for instance. So this is hardwired into the PLC. I've also got HMI signals. So you've got HMI manual, HMI start button. So those are also inputs. But obviously you can have either your physical inputs or your HMIs. And then we've got obviously our outputs, right? Which is, you know, the one that drives the motor on and off. Simple as that. So we've got start and stops. We've got modes, selectors, right? Like local remote or hand. In some cases they call it hand or manual. So you can have multiple things. So, but what do those signals have in common? What they do have in common is the fact that they are all part of the motor. So those we should treat them, we should regard them as part of the motor, right? So this is why we're going to create a user-defined data tag, right, for this motor, which I've already done it. So I'm going to show you guys how it's been defined. So user-defined. So in order for you to create a new tag, right? So this is where you basically create all your user-defined data types, your aka UDTs. So if I double-click this, every single bit that you see on that logic, you see, so you've got, for instance, all the I's are inputs. So, for example, we have an input, which is a Boolean, like an atomic data, right? An atomic data, Boolean, which can either be either 0 or 1, okay? So a bit of a description to make your life easy to debug and to organize your code. So this, for instance, is an input, a physical input for an emergency stop. I have a physical input for a stop button, so this is a stop push button, you see? So all those I's, they are physical inputs, all right? Obviously, iPerm 1, 2, 3 shouldn't be a physical input, but don't matter. I'll get those ones fixed. The whole point is to show you what is a user-defined data type. So what else? So on the output side, we have our motor, you see, which is a Boolean. We've got a couple of timers. So you've got some delays. For instance, if you have an alarm, it's going to take a certain amount of time. So you've got fail to start. So there's going to be a delay for lockout. So there's various things. You've also got the Hmi command. So you've got Hmi manual. So if you look at the description, if it's equal 1, that Boolean, Hmi _ man, is going to be in manual mode. If it's equals 0, it's obviously equals to auto. So you can use the same input. You could also have another Boolean called auto, Hmi auto, for instance. But I've only set 1, which is enough, really. But it's down to people. It's down to the way you design your software. It doesn't really matter. All right. So as soon as you create all those tags, this is your tag name, right? So your tag type. So basically, as soon as you push OK and apply, your tag now becomes pump type A, right? Let's just click on it. So now it's the beauty. Let's just say you've got one pump called pump 20. So P20, we're going to call it P20, right? So if I as we've seen it before, if we use the shortcut Control W, it brings you your new tag editor. So if I call this P20, our pump 20, so we're creating a new pump called pump 20, and we're just adding a description here, right? Pump 20. So data type, this is where we use our user-defined data type, which is called pump type A. See, it's gonna be sitting on the controller scope, and we just push OK. So now, if we go to the parameters, the controller tags, so obviously all those tags have already been created, right? So those are individual tags, but look down here. So down here we have the latter, or obviously the last tag we've just created. He's always sitting down here, right? Let me just filter by it so we can easily see only it. So you can filter by typing here, anything that matches some of the strings, some of the text, right? So basically, this is our data type. So you can see that you can't see anything on value because obviously you have to expand that. But see, data type is our user-defined data type, which is called pump type A. So the data type it's based on the hardware. So it's based on obviously not only the hardware, but the way you're designing, the way you intended to design your code. So let's just expand this bit so I can show you. You see, every single bit that we've created, no matter what type, what data type, every single one of those tags they're going to be sitting here. So it's basically if we just recap what we just seen. So do you remember that we have atomic data type, structured data type, and array data types. So this is actually a structured data type. So it's a series of other data types, different data types, which they are comprising in a single data type, which we define, we set out. All right. Okay. So lovely. So this is our P20. So let's just assume that you want to use that into your logic. The reason that we're creating now the data type is because the next couple of chapters we're gonna be talking about add-on instruction, which is basically a function-defined block. This is gonna be very interesting. We're gonna this line of code that I showed you here, guys. We're gonna be reusing the same logic, but we're going to encapsulate that into a reusable function block. This is gonna be nice, and I think this is the subject of the next video. All right. But let's just for out of interest, let's just go all the way down here, and I'm just going to type chick plus OTE. So, and I'm going to show you guys, for instance, P20, because we created, and then dots. You see, if you expand that, you can actually select all the tags that sits within your data type. So if I want a HMI start request, for instance, see, oh, this is actual set point. So this is obviously going to be an error because this is a double integer. What you want here is a Boolean. Just to show you guys, you see. So that as soon as you select the tag, you've got the tag. So basically your structure is going to be like your data tag, dot, and then the element. So if you type your data tag, and then as soon as you type dot, and then brings up all the tags that sits within your data type. All right. Let me just select another bit here. So start push button. Look, and then the description comes up on top of it, which is pretty handy. All right. Okay. So just before we finish, it's again, it's another longer video. I'm trying to make shorter videos, but it's just been difficult. But never mind. We wanted to cover the whole subject, right? Let's just before we finish. So this is how you create a new data type, a new user-defined data type, UDT. So select here, let's just call this, for instance, valve A, right? So valve type A, and then I'm just going to show you, for instance, I don't know, valve, let's just say opened, right? Opened, and then we have closed, and then we have open command, CMD, for instance. This is it. So all of those objects are Boolean, right? Because they are single bits. And see, so and then you can type your descriptions, right? So this is valve closed. Pretty simple, right? And this is valve. This is open command. Right? Lovely. Simple. Obviously, this is not complete. We would need more tags here to have a fully function user-defined data tag for a valve. Let's just apply. I just want to show you guys how you do it. Right? This is done. So if I wanted to create a new tag, so Control W, and then let's say valve 100. Oops, wrong here. So valve 100, and what you do here, data type valve. Yeah, boom, tags in there. So if you go back there, screw all the way down, obviously it's filter, take the filter off, just type valve 100. See, all those signals now are in there. See, they are sitting on the scope within your valve 100 and data type valve type A. All right, okay, so that's all for today, folks. I hope you enjoyed this video. So obviously, if you do like the content, so make sure you do subscribe. If you do like the content, just please consider subscribing to our channel. If you do so, just make sure you ring the bell to get notified about our latest videos. So obviously, likes are very much appreciated. So make sure if you have any questions, leave in the comments down below. You can always find us easily on Instagram. I'm gonna leave all the details on the description of these videos. So obviously, a couple of links, so you can access some of the menus for Studio 5000 Logix Designer. So obviously, like I always say, always RTF M. I'll see you guys next time. Stay tuned.